seeds.
You can plant these. Or you can eat them. These are like dry beans that you buy in the store.
Oh, wow. But you had to soak them.
Then you have to soak them, yeah. But I that way, if you get an organic seed that's not been hybrid,
Yeah.
you never have to buy bean seeds again, ever.
Now you don't have a void in the soil. So that if you pull one group out, you have another group that comes in. You have this very dramatic change in the soil microflora.
I like the more of a rounded tip instead of they taste better.
Pathogen. Genetically modified to be resistant to the chemical glyphosate and the weed killer Roundup.
Monsanto investors are concerned about reports that corn crops at several farms in northeast Iowa are being attacked by destructive pests, and there are fears that the Monsanto crop is spawning a superbug.
On January 17, 2011, Professor Don Huber wrote a confidential letter to U.S. Agriculture Secretary Tom Vilsack, alerting him that a team of scientists had discovered an unknown pathogen. The new pathogen was found in high populations in U.S. corn and soybean crops, specifically crops that have been genetically modified to be resistant to the chemical glyphosate and the #1 selling weed killer Roundup. The new organism was linked to an epidemic of plant diseases that had spread across Midwestern fields and found in cattle and dairy herds that were experiencing infertility and spontaneous abortion rates as high as 45%. Professor Don Huber is an internationally recognized plant pathologist and professor emeritus at Purdue University. For the past 40 years, he spent his career as a scientist working in professional and military agencies that evaluate and prepare for natural and man-made biological threats.
The bees deposit the nectar into the cells of the wax honeycombs they've built. They fan it with their wings until most of its water content evaporates in the warm air of the beehive. What's left is thick and gooey honey. The bees then cap each honey-filled cell with beeswax. That's when the beekeeper steps in.
We have a tremendous impact on the sustainability of our animal production, because with alfalfa as a perennial crop, open pollinated with an insect vector, the bee is the vector for the pollen, that in 5 years you won't have anything except Roundup Ready alfalfa. There's no way to maintain a non-Roundup Ready population of alfalfa. The last 2 years we've had a very significant epidemic of Gauss's wilt on corn and sudden death syndrome on soybeans. We've had to increase the rate of glyphosate, so we've just continually hammered against those organisms that would give us some natural biological control of that disease.
Why are the issues with glyphosate relevant to the discussion about genetically modifying crops?
Glyphosate is the chemical name for that compound that is attributed for herbicidal action. Roundup is a formulated product that includes other components besides just the glyphosate chemistry in order to increase its penetration into plant cells or its activity as an herbicide. When you have a genetically engineered crop that's resistant to glyphosate, it not only permits the wider use of the glyphosate, the extended exposure to it, but it also permits then the application of glyphosate directly on that crop, which many times we're consuming. What you see is that after a period of time of continued use of just one herbicide and increasing rates of that herbicide, which have been very dramatic in the last 10 years, that you see pretty soon that entire groups of organisms just cease to exist in the soil. Now, you don't have a void in the soil, so that if you pull one group out, you have another group that comes in. You have this very dramatic change in the soil microflora and that soil biota that affects these soil-borne diseases very dramatically. And that's because glyphosate is not only a very powerful herbicide, but it's also a very strong biocide. Very selective in the soil, but it stimulates some of our soil-borne diseases, and it also changes the soil microflora that affects nutrient availability then for the crops. One of those critical components in that soil microflora that disappears with glyphosate or is severely suppressed are those organisms that make manganese available for the plant. When manganese is reduced in the plant, again, it becomes very susceptible to this pathogen. And so you have a biological component that is very powerful because of the powerful biocidal effects of glyphosate, and you also have a direct effect of glyphosate as a very strong chelating agent. Now, by chelator, we mean that's a chemical that can grab onto another micronutrient or other mineral element that's essential for a plant and immobilize it. And when that's immobilized, then the plant goes into a deficiency or reduced efficiency.
These beets are a little larger than, normally people don't let beets get this large. This cylindra beet, which is a long, thin beet,
Yeah.
never gets tough.
Oh.
So it's okay if you let them get bigger. I mean, it's not critical that. And you can actually store them like this in case you need your rings.
Really? And they say like,
Oh yeah,
okay.
you got a good seal. See, it's dipped in.
There we go. Thank you.
Through plant breeding, we can combine the best features of different plants to make these better adapted varieties. but saving the diversity is a prerequisite for using it.
And so the Global Crop Diversity Trust was established to provide this type of long-term funding to protect the crop species that we're all dependent upon.
We have resources that are available for the long term.
So if anything goes wrong in a plant gene bank around the globe, you can go to Svalbard and retrieve the material. Svalbard is the final backup. Svalbard is a very important part of the global system. But our job is also to make crop diversity available to the farmers, the breeders, and the scientists.
Crop diversity is the biological foundation of agriculture. And when you look forward at less nutrients, less water, less energy, then the one thing you know that you're going to need is more diversity.
The U.S. Department of Agriculture evaluates new agricultural chemicals. The chemical preparations are used to kill insects and to change the growth of plants. The chemical industry supplies the USDA and also the Food and Drug Administration with samples of their products. With herbicides, the weed killers, screening and evaluation extends to field plots, where plant varieties are correlated with families of chemicals.
But in trying to find out what was causing our animal producers to go out of business, literally, because of a high mortality and inability to reproduce, that they started looking at the feed. Said, how are they being infected? Where's this organism coming from? They then traced it to soybean meal initially.
It's fortified with vitamins and minerals and contain calcium to strengthen the eggshells. The hens drink water from nipple-ended tubes attached to their cages. All these carefully monitored conditions are designed to maximize the yield. The hen's manure drops through the bottom of their cages onto a conveyor below. Even so, some eggs get dirty. They'll be thoroughly cleaned and disinfected later on.
The skins drop onto another conveyor belt to be processed into pork rinds. Meanwhile, the meat pieces head toward a flipping device that turns them backside up, so workers down the line can trim off any remaining pieces of skin.
Manganese is very critical for all of our defense reactions and detoxification of the mycotoxins. Roundup Ready soybeans, for instance, there are scientific peer-reviewed papers showing that you have as much as a 48-50% reduction in manganese in that soybean seed. You see the same thing in corn, a reduction. Mineral content quite often is very significantly reduced, not just for manganese, but for other essential nutrients. Stillborn calves, generally with manganese deficiency, will have kind of an arthritic appearance because manganese is required for calcium deposition. Same thing in man.
If you watch an amoeba long enough, you may see it engulf something. This one is surrounding a small ciliate, a nice dessert topping off its meal of diatoms. No community would exist for long without scavengers, and in the micro-world, Coleps is the jackal. These are feasting on a paramecium carcass. In Vorticella, a band of cilia-stiffened membrane is used to generate feeding currents. The bacteria selected are engulfed in a food vacuole that pinches off and circulates through the cell while the bacteria digest.
Fungus has no stem, no root, no leaves. For most of the time, it's nothing more than a tangled tissue of branching threads. antids are cannibals.
Nature often saves scariness for the vegetarians. You see, they need to deter their predators.
Around the world, more than 1,400 insect species show up on menus. Insect eating, or entomophagy, is part of healthy diets in Asia, Africa, Australia, and Latin America. This trend is anything but new. Archaeologists have found evidence of it dating to the earliest humans. Producing a pound of caterpillar takes a tenth of the resources needed to produce a pound of beef. And insects brim with vitamins and minerals.
Preparing a cricket cocktail. It's a lot like a shrimp cocktail, only instead of shrimp, we use crickets.
Americans will be snacking on everything from caterpillars and cockroaches to mealworm-covered apples. It has a big, bulbous head, beady black eyes, and 8 squirming tentacles. It's the octopus. Many would call it ugly and disgusting. The one thing they wouldn't call it is dinner. But in Korea, octopus is considered a delicious treat. And there's one popular way of eating it that doesn't require a recipe. They don't cook this 8-legged beast. They don't even kill it. They eat it alive.
Actually, I was taught in America, if it's alive, don't eat it. And I come to Korea and it's alive and they eat it.
Tons of sea snakes are removed from the Gulf of Thailand and shipped domestically and internationally to be eaten. These are highly venomous snakes, and they end up in soups, in drinks, or they can end up as a traditional medicine.